You're watching the .NET Doc Show with your hosts Cam Soper, Scott Addy, David Pine, with special guest Chase Aucoin, and that's me. The show starts now.
The live version. That's so cool. Welcome, friends around the world. We've got a special guest today, and if you've been following us for a while, you will have seen our good friend Chase many a time as our opening .NET show kickoff announcer aficionado, right? So he's been a great asset in that regard, and we're excited to have him on the show. And Chase, say a few words about yourself.
Thank you for having me here. My name is Chase Aucoin. I am the Director of Engineering at the Paciello Group. We are a firm that specializes in helping with accessibility for Fortune 500 companies, as well as small and medium businesses. And we do a lot of really cool stuff, making sure that the world is accessible for everyone. And that's me. We also do a lot of open source projects that help make working with .NET and working with applications easier. Yeah.
Awesome. Yeah, we're super excited to have you on. Had a little bubble there in my throat. Excuse me. Super excited to have you on. Thanks again for coming. We've got a lot of interesting things that we're going to talk about today. But I just wanted to address the elephant in the room, which is everyone probably has noticed that we've got our Twitter handles here under our names. And I'm reminded of the fact that at our little bumper video at the start, we've got the .NET Docs Show Twitter account. And I wanted to share this story real quick. So if you've been following that Twitter account, the new Twitter account that we created, it's actually locked right now. It's going to say that it doesn't exist, and Twitter has basically killed it. And the reason is because we wanted to get it verified. And part of the verification process is that you have an actual birth date that's visible on the account, or you have to provide one. So we put the start of our .NET Docs show, and that was February 27th of this year. And then immediately the account was locked, and Twitter's like, you're not even 13 years old or 18 years old or whatever the number was, but they're like, you can't have a Twitter account. So I've already sent them my passport and my license, and I tried to get it reverted, but we can't. So we apologize if you're trying to look for that account that we're still referencing in places and it's not there. That was I just wanted to call attention to that. Sorry.
The takeaway is it's all Dave's fault that
we
don't have an official Twitter account.
And that has nothing to do with our show, but for our show, Chase, what are we going to talk about today? What are some of the things we've got lined up?
Well, I think we're going to talk about microservices. We're going to talk about remote work and a pandemic, and making sure that teams are accessible regardless of need. And kind of how the pandemic has highlighted and is starting to make things easier for everybody and creating more opportunities for people across the board. And I think that's super exciting. Obviously, the pandemic itself, not super exciting, but you know what I mean.
Yeah, no, that's definitely a good way to look at it. I think that's kind of embracing the growth mindset, because a lot of times you hear almost the opposite, that the pandemic is taking things away rather than creating opportunity. So that's exciting. I'm looking forward to that. So let's kick over to our checkup. Supposed to be sharing a screen, I thought.
Yeah, I'm on it.
He's on it. We're doing it. We've got a screen here.
All right. Welcome everyone to the checkup segment. The content we're sharing today is actually directly related to the topic of microservices, sort of taking a step back, like before you even get into the nitty-gritty of microservices. One thing you should really understand is containers. Naturally, that leads us to the topic of Docker containers. And since this is a show focused on .NET, we have a doc here that tells you how to containerize a .NET Core app. The example it uses in the doc here is .NET Core console app. And so if you scroll down, you'll see, okay, it's going to use the .NET Core CLI to scaffold a new console app. It'll send it to this app folder and call it netcore app.docker. I wanted to say doctor, but that's Docker. It goes on and shows you everything you would need to know. I guess I would describe it as the essential information that's needed to containerize a .NET Core app using both the .NET Core CLI and the Docker CLI. And further down in this doc, you'll find there's an explanation of the various commands that you'll find in a typical Docker file. For example, what does that from statement mean that you see everywhere in Docker files? You'll also see information like how to start and stop Docker containers.
And Scott, does that doc describe the multi-stage, like the multi-stage Docker file that we see like in a lot of GitHub projects?
Yeah, it does show the build output. I don't know if the Docker file being used is multi-stage or not.
No, I don't think this one does, but I can kind of elaborate a little bit on this too, because I helped out with this recently. So in here, one misconception is when people look to containerize a .NET Core executable, a lot of times what they'll do is they'll make the assumption that they could start with hello world, and you can, but then that's a one and done execution of that container in most regards. So typically, it's great from a microservices aspect to have something that's going to be long running, almost like a service or even a web server, things like that. So this specific example actually changes the main body of the console app to be a continuously running process, so that you can see like the various outputs and you can plug into that and kind of understand the whole semantic flow of the container orchestration, like starting it up and running it and getting piping into the output and stuff like that.
One other thing I'd point out here, it occurred to me as I was talking about the various CLIs that are used. You might be looking at this doc, the doc we're sharing here, and saying to yourself, well, that's all using these command line things. That absolutely terrifies me. I'm a Visual Studio user. What about me? The good news is we've got you covered. Over in the table of contents, you'll notice the next entry down would tell you all about the containerization tools for Docker that are baked into Visual Studio 2019. Did we also have a aka.ms link to share for this doc for the folks who are watching?
We do. aka.ms/docker-.net.
Yes, so if you're interested in anything we just talked about, please do check out that aka.ms link. Should we roll over to the hallway track segment?
Let's do it.
So one of the things that people don't know about don't know, but I think one of the things that gets missed whenever we think about containerization with .NET apps, because many .NETers, this is their first foray into Linux, and kind of their first introduction to containers is through some of these automated tools and things. There's some nuances that can get missed. One common use case is whenever you need multiple services within one container. And this would be analogous to whenever we're dealing with Windows machines. We might require multiple services for each instance of a Windows server, to have multiple services, maybe one that's running as a singleton, maybe one that's doing some background cleanup stuff, notifications, etc. And there's a couple different ways you can do that. You can have those each be separate containers, but you can also use supervisor D and host that .NET application as a service and have many of those services running all at the same time. So you're not limited to just having one executable running. And I think for many people, if this is their first introduction to that, they think that you can only have one application running within that container, but you can have as many as it really is analogous to a traditional computer. It's just more compact, and the way that it is managing the instruction set whenever code is being executed is different from a traditional VM. But other than that, everything that you would do on a traditional VM, you can do inside of a container.
So let me ask you this. So you basically just described that you can run multiple processes in a single container, right? Okay, so why would you want to, like, if you're architecting an application, why is there any case where you would want to do that? Is there any case where you wouldn't want to have each service or each component of your application living in its own container?
It depends on the way your individual application is architected. But a good example of that might be, let's say you wanted to have a worker of some kind that's in the background doing things to the file system for what you're exposing out to the world. An example might be, let's say you're doing image processing out of your API, and to handle these larger files, you need to set them off to the virtual file system to chunk through them and do the work. But then once it's done, you need a task that goes through and cleans that up every so often. So that's an example. And there are many similar things that you would see in kind of a classic deployment scenario, where you've got helper processes in the background doing things. And it also just depends on what your scale strategy is and how you're managing data within your application. There's so sorry, go ahead.
Well, I was just going to ask a question on that. So, like, is that in opposition to like a monolithic application that might, playing off of the example you just outlined? Imagine you've got this image processing service, and when it's done chunking through and processing all those images, it would have something else that would do the cleanup. So why not have a monolithic app for that?
Well, so a lot of it comes down to how you transition existing application architectures. So one thing that we tend to forget sometimes is that companies have spent millions of dollars in some cases, and in some cases decades worth of existing application suites and existing infrastructure that they need to modernize. And you can't always just re-engineer everything that you've built. There's a lot of value to be had in these existing assets. But there are ways that you can kind of tilt your head to the side a little bit and take your existing infrastructure, modify it a little bit so that it still fits within the constraints of how you can organize broadly, but without having to completely rip out the guts. So if you were bound for a single worker to its local file system, but then switching to a file system like blob storage in Azure might be too much of a lift or just take too much time. This is kind of like gives you an opportunity to have a step in between.
Yeah, so it's almost like you get an opportunity to kind of separate these concerns rather than having a giant monolithic app. You could segment them and isolate them, and then they can scale out independently. And you can do other things like individual error handling. So, like, for example, if the image processor in our scenario here that we were kind of outlining would fail, the cleanup can still happen because it could be independent of that. So there's no like direct dependencies on things.
That's correct. And it doesn't stop you from, if it makes sense. A lot of it comes down to like what is comfortable and what makes sense for the development team that's working. There's a lot of ways to do the same thing in what we do. And people tend to get locked into like, oh, this is the right way. Then there's only one right way, but there very rarely is only one right way. There are lots of right ways. And so you can take that same thing, and then if you want to get to the next phase and start splitting out the file system, you can use product like Azure, what's it called? Azure file share as a distributed file system that is underneath all of your containers. And then you can use container groups in Azure to put two containers right next to each other, and effectively it's like they're working against the same local host. From a distribution standpoint, they're still right next to each other, but they're a little bit more separated out. And then as you have more scale concerns and as things need to be further broken apart, you can continue to break those things as needed. And so the idea is that you don't necessarily have to go to some incredibly distributed, incredibly decoupled system all at once. And I think a lot of people, want to really get into microservices, they think they have to start at the end, and that's just not the case. You can start wherever you are, and start breaking things apart over time.
So it's possible to take a monolithic app and start kind of segmenting it such that you start building out microservices from little parts. You kind of cherry pick and start building it that way.
Absolutely. And one of the things that I've got that's helpful with that, I've got a product, it's an open source project called Cupcake Factory.ServiceProxy that helps with some of that. I'm going to share my screen real quick. Let's see.
You said Cupcake Factory? I love cupcakes.
Oh, yeah, everybody does. So Cupcake Factory started with a company I was working at a long time ago. We were joking about how everything was getting like super abstract. We're like, well, we should just take that to the next level. And instead of services, we'll have cupcakes.
I love that. That makes sense.
And instead of decorators, we'll have frosting. And but some of those naming conventions didn't make it into the final thing. But the goal here is how do we easily work with services? So one of the things that we see a lot, or that I see a lot in shops that are working in .NET, they wind up adopting ideas from old documents and old articles on how to put services together. And unfortunately, we wind up putting a great deal of extra work into the developer for not a lot of extra value. And I'm very anti that. I'm pro hard work, but I'm not pro work for work's sake. And so with ServiceProxy, the goal is very similar to how WCF used to work. You've got your interfaces for services. Here I've got just two simple services, an addition and a subtraction service. I've got a service that implements that, both of those. And then as far as hosting it, hosting becomes very easy. So instead of having a service and then proxying that service through a controller, you can just work with that service directly. So this is a standard setup file for an ASP core website, and in our services, we're providing our concrete service for our interfaces, and then with ServiceProxy, all we do is just add proxy to whatever the interface is. 1 second. And what this will do is this will do all of the wiring up so that you don't have to add that additional step of putting controllers in the middle. And because this is just using the standard application pipeline, anything you want to add as far as authorization, authentication, or any additional middleware in between that proxy still works as you would expect. It doesn't.
Interesting.
And then from a consumption standpoint, it kind of lowers the barrier of entry on the consumption side as well. You just pull up an HTTP client. Again, if you have authorization, if you have JWTs, things like that, the reason I have it set up this way is any of those default headers that you want to do. So let's say in our default request headers, we wanted to do.
Is there any way you could zoom in on this text a little bit?
Yeah, absolutely.
Perfect. Thank you.
Do this. Close this down, and we'll cinch this up a little bit. Is that better?
So for clarity, Chase, for folks who might be wondering, service proxy, if we take a step back, is this something you wrote, or is this a product that
this is something I wrote? It's MIT license. It's an open source.
I just shared the URL for the repository.
Oh, awesome. Thank you. So yeah, it's an open source project that I did, and we use a very similar version of this in day-to-day. I've been using the same technique for nearly a decade, so it's pretty battle hardened from that perspective. It doesn't catch every edge case, but it also wasn't intended to. It's meant to serve 90% of the use cases, and it's a little bit more. It's less flexible and more opinionated.
Real quick about those opinions, I think it's a good opportunity to kind of interject there real quick.
Yeah.
So I know that years ago, Uncle Bob Martin and Robert Fowler and others kind of initiated this Agile Manifesto, and you had done something similar to that with the microservices. So I'm going to share another link here real quick.
Yeah, awesome. Yeah,
this is in a second. I mean, but this also brings in some of those opinions, I'm assuming, right?
Yes, some of them. It's a little. This is more opinionated on the technical end. That's more opinionated on the
conceptual or
the conceptual side about what microservices are and how, what they're intended, what the problem set that they're intended to solve is. But cool. But then on the consumption side, after you set up your HTTP client and you point it to wherever the host is, all you do is just do get proxy and whatever the interface is. So you can share that interface as a NuGet package or whatever as a private NuGet package if you're using Azure DevOps or any other kind of private NuGet feed. And that way you don't have to share any of the implementation details, but consumers within your organization can still interact with the service as though it were an in-process service. So from a usage standpoint, I find it tends to be a lot more straightforward for engineers to come on board and to start working with the services, because working with an interface is very familiar. You get all of your nice IntelliSense, et cetera, and very specific contracts to work with. And there are other ways to do similar things. You know, you can use Swagger and you can generate proxies from that. There's a lot of services to do that, but having to do that step each time can be a little bit wearing. This kind of provides a way for teams to work together and version their services, service contracts, and still maintain that kind of reliability in between services, so that whoever owns, you know, iAddition service or iSubtraction service or whatever your service is, it's up to them as the owners of that service to care about the reliability of that service, the speed of that service, et cetera, versus putting that on the consumer.
So can we see what the service side of this looks like again? So
Yeah, absolutely. So the service side is so whenever I think about services, I think about conceptually two different things. There's the host and the actual service itself. So on the service side, it's just a traditional, it's a plain old service. So rather than a POCO, plain old service object, it defines methods, and those methods can be whatever. They can be tasks. They can return types. And they can be pretty much any inputs other than delegates, because delegates you can't really do over the wire. So ultimately, any of your inputs and outputs have to be something that can be concrete at the time of serialization.
Mm-hmm.
But outside of that, your services are very simple. This also makes it easier to write services for engineers, because it's just like working with any internal service that you might do as a service, as you're thinking about, like in a single process, but it lets you remote against that pretty quickly. And then on the host side, to host that in our startup, we just say, here's our contract. Just the standard way that you would do if you were, say, using controllers, where for this contract of a service, this is the concrete version of it.
Mm-hmm.
And then down in the startup, all we're saying is we actually want to be able we want to wire up a proxy for that contract. Under the hood, it will use it'll use all the service collection to find that and inject that in the middleware whenever somebody makes a request to that interface.
Now, is that add proxy method an extension method from Cupcake Factory?
It is. It's an extension method from Cupcake Factory. You just take on CupcakeFactory.ServiceProxy.
And so does this allow for you then to more clearly separate the contracts, the interfaces, and the actual implementations?
It does. And what I like about this is let's say I'm a consumer, and rather than a console app, let's say as a consumer, I was another web application. And you'll find this quite often where web applications need to consume other web applications. If I needed to do testing and things like that, I can test against that contract, and I can make assumptions against that contract without actually having to care about the implementation of it. And likewise, from the standpoint of starting with a monolith, if you have these types of services that live internally within that monolith, it provides the opportunity to say, okay, which of these services are creating the most amount of memory pressure, most amount of CPU pressure? Can we take those out and segregate them away from our primary UI or some other important process, so that whenever those services are really taking a lot of requests, it doesn't slow everything else down.
So to your point, it's a lot easier to actually start profiling and using various diagnostics tools to kind of analyze potential shortcomings within the app and contention and things like that, whatever it may be, when you start to actually kind of isolate them and have them separate, right?
Mm-hmm. Yes, very much so. It's also nice just from a dependency injection standpoint. So as you start going down that pipeline, it's amazing. But in 2020, there's still a lot of organizations that are only just now starting to get into testing, get into dependency injection, and flipping how objects are getting created around, so that any dependencies for a service are coming in through that constructor.
In that same vein, I think there's still a lot of customers out there who are looking at this microservices trend, and they're wondering, why should I consider doing this in my, within maybe just my immediate team, what are the big advantages? Is it improving your team's velocity, or what are the benefits from your perspective?
So from my perspective, a lot of people, whenever they start going into or getting interested in microservices, it's because they've got bottlenecks, and a lot of times they'll look at it from trying to solve technical bottlenecks. But really where microservices become super valuable is in process bottlenecks within an organization. So let's say you start with a monolith and you've got all of these points of value and all of these services that provide different functionality to that monolithic application. And you've got a lot of people working on those all at the same time. What happens with those monoliths is, as more people come on board, the potential for two people to make colliding changes within the same thing or on dependent structures goes up exponentially with each new person that gets added to that project. Whenever you start to decouple those things, it does a couple of, it creates a scenario to where people can have real ownership over how a particular segment of the system should operate, both and ideally all the way from the data and then all the way up to product management, and how and what features are going to be a part of that. The way we tend to break that down in organizations is via domains. And usually you'll have large domains. Those domains may have many services within those domains, but then those domains are owned by like either one or many domains will be owned by a team. And then you get kind of a natural sharding that happens over time. So let's say you've got one large team that owns all of the domains initially. Well, as some of the domains get too large and unwieldy for one team to manage, you can split that domain off and maybe just have one or two people branch off and then start to build out that team around that domain. And then you've still got all these other domains by the main group, and then continue to branch off from there. And then likewise, as those domains grow larger over time, and added complexity and added functionality, they too may split and say, okay, well, now for this domain, we've got several subdomains that we need to split off because the teams are growing too large. So it gives it's almost like a B tree, the way that it splits out naturally and organically over time, and
So-
allows you to scale to infinite number of resources.
So putting that into concrete terms then. So because I'm putting this in context of like the microservices, Microsoft Learn modules that Scott and I have been working on. So what you're essentially saying is that you could have you might have a team who their job is running the storefront app, right? And as the app grows and as the as the complexity of the app grows, that you might split out, say, the payments section of the storefront into its own team and its own service, and their job is to just manage the payments end of it, right? Is that what you're?
Yeah, and it may wrap up into a larger domain. Maybe it's billing, and then billing is payments, invoicing, and a couple of different things within that larger group. And there's a trick to know where the domains are, and it happens at every organization. Every organization knows what their domains are inherently, but yet it still winds up befuddling them. Easiest way to tell: look at the database structure, find out the prefix. Look at the prefix on tables. That's
Love that.
probably gonna tell you
I've seen that so many times.
exactly where the domains are. Invoice underscore something, invoice underscore something.
Right.
Same with classes. If you've got classes with a lot of the same prefix, there's a good chance those are all part of the same domain.
And I think naturally this is where architectural patterns like domain-driven design would come into play. To your point, look at the prefixes on the table names. That could help guide you in going down that DDD path.
Absolutely. And there's a lot of overlap between DDD, test first, microservices. Like it's no one thing, right? It's just been this kind of slow evolution over the years where we started with SOA. Well, we started even before that, but really, I think the first big stuff after the Agile Manifesto was, we saw a lot of SOA type things, and really microservices is just an extension of that service-oriented architecture. Sorry, I'm bad about acronyms. There's too many acronyms in our business.
Naming
Alphabet
things.
soup.
I was just going to add something real quick here. I think it's really fascinating that, and this is probably a very common oversight, because I know I didn't really think of that as being a benefit, but you're alluding to the actual development rather than just, some of the benefits with testing and some of the isolations once the things are actually running in different environments and interactivity and whatnot. But you're actually talking about how teams develop and how, coming together and working in these different domains and kind of in these little encapsulated areas, there's actually that benefit that is often overlooked, right? Like there's times where we might take that for granted, but it's just another benefit. And I appreciate you calling attention to that.
I think it's probably one of the biggest benefits, because there's a lot of good that happens whenever you give people real ownership. A lot of times, and it depends on the organization and what their culture is like, but in many organizations, engineers don't feel like they have a lot of ownership, and just feel like they're being told what to do rather than asked, hey, how can we make this better? And people love to help. People just love to help natively. And if you give people room to help, they will, and they'll make awesome things most typically. So yeah.
And that gives them like technical freedom too, right? So they can choose, like in our little silo, our little microservice, if we're happy with Python and we're going to have this domain knowledge that we're bringing to it, we can do that, right? So you can really, the monolithic app that might have been written in one technology can be broken apart and rewritten with microservices and be truly polyglot.
You can do that. There are some technical hurdles. There are some technical organizational hurdles that you have to be careful for, or rather organizational landmines that you have to be careful for whenever you start taking that approach. Because if the organization as a whole has a general way of doing things, it's typically good if there are some rails, not like hard rails, but as an organization, if you've got some rails, it makes it very easy for, if all of a sudden the people working on domain B for whatever reason aren't available to work on it anymore, somebody else can come in and start working on it and take care of it and get it fostered up. If each team is doing very different things architecturally, you can get into some difficulty there, and it depends too on the domain. Like if one team is doing a lot of data science and machine learning, there's a good chance they're going to be running on Python and doing things like that. But if the domain is doing business-oriented work that's mostly like CRUD and BI type applications, you're probably going to have a strategy for that your organization is going to use overall. But that said, one nice thing about this approach of microservices also comes in the form of taking on other orgs. So let's say you're a company, you're a startup, and you've started growing over time, and you've gotten large enough to where, hey, we've got these additional things that we really need to add into our ecosystem. Let's buy a company. And if you're very good at a microservices and an API-driven environment, your ability to rapidly onboard the functionality and assets of another organization goes through the roof.
That is a situation I've witnessed out in the wild. I worked for an insurance company once where they acquired another insurance company because they wanted to start offering a different line of business that they weren't previously involved in. Along with that acquisition of the other company came this different set of technologies, MySQL database, for example, instead of SQL Server. And I think in a situation like that, microservices might be an appealing approach.
Definitely, because if everything's containerized and you're just working over the wire over standard HTTP protocols, because even with my service proxy, while it does a lot of the lift for you, at the end of the day, it's still just it's just making regular HTTP calls over the wire. It could be consumed by any other language. And it'd also be easy enough to just move over to a conventional route type system if need be. So there's a lot of ways, there's a lot of benefits to that. So if say an organization was predominantly using SQL and then there was a product offer that they needed, but it used MySQL or Mongo or Redis or if those things are containerized and orchestrated and set up to use persisted volumes, well, then it doesn't really matter. That can live in any environment. It can live in Azure, it can live on-prem, it can live in AWS. It really doesn't matter.
So one other thing I wanted to ask you about, Chase. So naturally, organizations jump headfirst into this microservices approach, and then they, decide down the road, oh, we need to start deploying everything to the cloud, right?
Mm-hmm.
Hopefully, that's not a lesser cloud, but no matter what their decision is, they eventually encounter this term of cloud native. Can you talk about what cloud native is? What does that mean to you?
Cloud native is super ambiguous, first and foremost. So really, for me, I can't speak for anyone else, but for me, whenever I think about what cloud native means, it's not so much cloud native; it's distributed native. It's building an application that can natively just kind of grow over time. And regardless of who is hosting your infrastructure, if you are building distributed systems and you're designing your teams in such a way that they can build in a loosely coupled way in those services, then you're building cloud native as far as I am concerned. But that means that you can build cloud native on-prem, or you can build cloud native in wherever. The big thing is that as a company starts to reach scale, and especially if it's something that is consumer faced, B2B apps don't it's not as big of a problem, but B2C, where you've got potentially millions, tens of millions, or hundreds of millions of users active per month, you're probably not going to want to host your own infrastructure around that. You're probably not going to want to try and house your own data center. You may, then there may be cost benefits to that, but for most organizations, the operational overhead and the costs associated with that operational overhead isn't outweighed by just saying, all right, I'm going to let somebody else who's really good at that and already has all of that handled and all of the pitfalls and caveats that come along with owning that, and just let them take care of it. So,
Chase, I'm wondering if you could talk a little bit more about something you kind of alluded to earlier when you were talking about like the Azure file shares, and you were talking about how, oh, you could have these, two microservices that both share the same file share and they're working, with the same, files. How do you see platform as a service offerings like file share, like, Azure table storage or Azure managed, what do they call it? The Azure SQL database managed instances. How do you see those fit into the architecture here?
I think it really kind of depends. So it depends on how flexible you need it to be. People are afraid of vendor lock-in, but I don't think it's necessarily fully warranted. What I have seen more often than not is the same companies that were afraid of vendor lock-in stopped being companies long before their vendor did. So that's not to say that's always the case, but especially if you're dealing with like the big three on the vendors, and especially if you're dealing with Azure.
I guess we can keep them on the show.
So for me, it depends on how willing are you to be locked into a product, and part of that too will be dictated by what you need from a how quickly you need to get something to market. So if you need something to market really quickly, and you need to know that the data store behind it is really well constituted and like put together well, and you don't want to think about it, that's where leveraging things like table storage, like Cosmos, like these incredibly massive scale projects can be super useful. And really that's about, there's always a like a cost benefit analysis that has to happen inside of your head of, okay, I'm going to spend a little bit more money, but my amount of time just plummets down to nothing to make this happen. And right. And so if you either have more time or you have more money. And if you have more money but you don't have a lot of time, then use built-in products that are ready to go for you. If you don't have a lot of money but you've got a lot of time, well, then there's a lot of opportunity to have solutions that cost next to nothing. There are patterns that you can use using container groups and using these types of file storage, where if you've got properties that really aren't getting a lot of traffic, you can host many of these properties for like $3 a month or less. It's really actually kind of ridiculous how inexpensive it has gotten. And then what's nice is that with all of these improvements that have been made to .NET Core and all these improvements that have been made to computer infrastructure at the same time, the language itself has gotten faster while machines have gotten faster, and overhead has gone down. So you can get a lot of value out of a micro instance that maybe only has 512 megs of RAM, but unless you're throwing a lot of people at it, it's probably going to be fine.
Let's zoom in a little bit on that, because I know that's one of your areas of interest that we actually talked about in the pre-show the other day. Was that the ridiculous amount of requests that can be handled with a tiny bit of hardware on .NET Core.
Yeah. So what I'm finding in practice is that more often than not, you're going to hit your network threshold before you hit your CPU or RAM with as efficient as everything is these days. As a good example, this has been a couple of years ago, but I bought 5 $150 home theater PCs. It had a 4-core, I think an Atom. It was an Atom or something like an Atom, but just a little 4-core micro PC in there. It had a RAM slot, so I upgraded it to 16 gigs of RAM. So I had a total of 20 cores, and like, so 16 times 5 was that 32, 64, 96 gigs of RAM for about $1,000, which is just insane.
That's crazy.
And I wanted to like stress test it. And so I set up Service Fabric on it, and just to kind of like get an idea of scale out and things like this. And I was hitting this threshold on requests per second. I'm like, man, why isn't it going any faster than this? It should be able to go a lot faster. The CPU's barely got any utilization, RAM barely got any utilization. What is going on? And I finally like had to sit down and think about like the size of each message. And I did the math at the threshold that I was hitting. I was like, oh, I hit my gigabit per second local network, and it just can't go any faster. Got it.
That's amazing.
So that I think folks know that I have a pretty big interest in IoT topics, and I love running .NET Core on a Raspberry Pi. There's just something satisfying about running .NET Core on a little credit card computer.
Yeah.
I kind of want to do a live performance test, set up some sort of a web app on a Pi and hammer it on the show sometime and see what those numbers look like.
Yeah, it's pretty awesome. It's always going to depend on what you're doing, but especially if your database is offloaded to something else, like the machine that's just processing requests really isn't. It's spending the majority of its CPU lifetime waiting. It's waiting on you to send the bytes over. It gets them, pushes them off somewhere real quick, and then is waiting for a response back from the database, and then is waiting for you to take the response. So the majority of the lifetime of an HTTP request is just the processor waiting. And that's where TPL and the task libraries and things like that have really just accelerated and made things super awesome for creating these high-scale development infrastructures.
I'm curious, Chase, did you ever build any microservices with .NET framework? I know you were talking about .NET Core. So if you have, I'm wondering what major improvements you realized.
I have used I've been building some form of SOA for years. Classically, that was in the form of WCF, and
ouch, WCF.
Yeah. And there were some good things about WCF, but you get into configuration nightmare with that real fast. But the big benefit that .NET Core has brought for me is going to be a surprising one. It's actually package management. .NET Core and the way that it manages packages, and that you've got this nice graph of packages where whatever your root package is what you're managing, rather than your root and all of its dependencies. Because there were so many times on classic .NET where you would get these sub assembly collisions, and it was just always painful.
Binding redirects.
DLL.
Yeah. I think what you're referring to is the transitive package dependencies. So now you're just defining that top level package that's needed to accomplish whatever task it is. That brings along for the ride the dependent packages.
That may be not the answer that you were looking for is my favorite thing, but that is it. Because there was so many times that I got into problems with the way the DLLs were routed beforehand. And then other than that, just the native DI, for most purposes, it gets the job done. It gets the job done really well, and without having to spend too much time thinking about how you're going to implement that strategy. It's just kind of already taken care of for you.
Yeah, I love that it's just a first-class citizen now with .NET Core. It's that's the forefront of here's how you should be doing it, and it's opinionated, but that's okay because, like you said, it covers most of the use cases, and it's really well done.
Yeah, that's one thing that I kind of go back and forth on with the direction of .NET. Sometimes it feels like, so one of the things that has made Microsoft really valuable as a developer resource for so long is their embracing of the easy button and just making things that developers do all the time just ridiculously easy. Sometimes we see, as these developers or these newer projects are developing, we're losing some of that easy buttonness in favor of robustness, and it's good, and but I don't know. There's trade-offs with that.
Chase, as you know, as the show's winding down a little bit. Dave mentioned earlier your Microservice Manifesto website, and I was wondering if you could tell us a little bit about the genesis of that and kind of the pillars.
Yeah, absolutely. So the Microservice Manifesto came from, I was giving a talk called the Microservice Manifesto for a while, and I was at a conference, and one of the attendees said, "Hey, do you have like an actual manifesto written down anywhere with any of these concepts?" I was like, "No, but I like buying domains, so I can do that." And really, the crux of it is the biggest challenge isn't technical. The biggest challenge whenever you're managing large sets of teams and large sets of services comes down to how do you manage the organization and the people around that. So the pillars are kind of meant to build on top of each other, starting with ownership, because unless there's ownership and unless engineers can get involved in the process and work hand in hand with product managers, any of the other things aren't really going to be hyper effective. And then next, automation, because as you're able to automate all of your CI/CD processes, it makes life easier. If you have hard time getting one thing out the door that's manual, imagine doing that with tens of things or hundreds of things manually. That's no fun. So automate as much as possible. And then if you've got automation, well, it's very natural to add testing into there, because then you can automate those tests. And then from there, discoverability. How do we make sure that the entire organization is aware of what is available? Accessibility. How do we put it in the hands of folks and make it easy for them to use? And then lastly, responsibility. If you've got all this ownership and if you've got all of these awesome things into your organization, then it's up to you as a development team to be responsible for the products that you're creating, and to make sure that the consumers of that product don't have a bad time because of it.
So you're basically declaring that we need to be responsible for the stuff that we write? Come on now, that's not logical.
I know, it's crazy.
Chase, you mentioned testing in the manifesto. That reminds me of something we were talking about in the pre-show, and you were talking about mocking services until, decisions have been made internally, and then once decisions have been made, you swap out the mock with the actual service.
Yeah,
can you talk a little bit about
this is a pattern
that
I really, really like. So let's say you've got you've got microservices, or you've got separated teams, and one team is doing implementation of a thing, including all of the database work that has to go along with that, and infrastructural work. Well, as a consumer or as a UI, and the part that is directly interfacing with customers, I can write out all the functionality that I need, and then just make a mock version of that locally really fast, because I don't really necessarily need the full implementation done. And what that lets me do is have better conversations with stakeholders, because if there's one thing you can say for sure about stakeholders, it is that they will change their mind. I don't care how much, whenever it's theoretical, they go, "Oh no, it's not going to change at all. I can guarantee that this is the way it is." As soon as they see it, they go, "Well, except for these 5 things, but other than that." So it lets you have that conversation, and that's an okay conversation to have. What's not okay is to have already pre-built all of this infrastructure and then have to go back and rebuild all that infrastructure, and then go back and rebuild all that infrastructure. So by having that conversation up front and getting that really nailed down, then you can work with the services service teams and get the back end data sources that you need to power that done. And then because they've already signed off on the theoretical version, as soon as you swap contracts to pointing at the live thing, it works, and it works exactly as it did before. So you get faster time to delivery. You get a more reliable and consistent vision of what the product teams wanted. Everybody ultimately winds up being happier in that scenario.
Awesome. Thank you for explaining that. Say we got a couple of minutes left in this particular episode. Are there any closing thoughts you wanted to leave viewers with?
No.
and no, that might be the best response I've ever received to that question.
Sorry, that's kind of on the spot. I don't know. But yeah, no, I don't. Nothing comes to mind right off the top of my head.
That's fair.
There was a lot there. We'll be sure to include all of these closing thoughts here in our TL, the Too Long Don't Read article that we'll have a Dev2 post following up, and we'll post this to YouTube. And as always, thank you so much for being the guest. You were amazing. Great conversation. I learned a lot. Thank you for sharing your opinions. And
I will add one thing. If anybody wants to follow up on any of these ideas, or anybody needs more clarification or anything, please feel free to reach out to me on the Twitter right there, and I'm happy to answer any question that or discuss or whatever. I'm here to help.
Cool. So real quick, next week on the show, we've got Layla Porter, who was actually, this is a timely episode. She was actually just appointed to the .NET Foundation Board. So we'll have some exciting news to talk about with Layla next Thursday.
That's awesome.
Awesome. Thank you, everyone. Until next time, take care.